Our next important topic is our Doppler effect. Okay, so your Doppler effect will almost come twice. I mean, in the recent years, they have been asking in 3 question papers almost 2 times. So either they are asking Doppler effect in sound or Doppler effect in light. So it is kind of important. So this basically comes in sound waves chapter, and in sound waves, okay, just I'll quickly do a recap. What is the recap is your wave motion. If you take that wave, what it will do is it will transfer energy and momentum. Okay, it will transfer energy and momentum. Any wave will transfer energy and momentum. Now if you take this sound wave, okay, it will be any wave will generally it will be in the form of some y equal to a sin omega t minus kx plus phi format. Out of this, a represents displacement, okay, omega represents angular frequency, okay, k represents wave number, phi represents initial phase, and your angular frequency omega is 2 pi f, that is equal to 2 pi by time period t. Wave number k is 2 pi by lambda. Your velocity of wave is omega by k, which is also equal to frequency into wavelength. And your velocity of wave here is sound wave. Okay, here this is your sound wave. This sound wave, okay, we have studied in which chapter? Previously in sound waves. Okay, I'll do recap first, then I'll explain Doppler effect. So this sound wave, if it is in solids, okay, if it is in solids, you will write velocity of sound is under root of Young's modulus by density. Okay, y represents Young's modulus, rho represents density. This is Young's modulus, this is density. For liquids and gases, okay, for liquids and gases, our sound velocity is v is equal to under root bulk modulus by rho. Okay, b represents bulk modulus. Your bulk modulus, okay, your bulk modulus according to Newton, okay, Newton and Laplace. Okay, first Newton thought isothermal bulk modulus is equal to pressure. P represents pressure. Later Laplace corrected it and Laplace gave B is equal to gamma into P. Gamma is 1 plus 2 by F, where F represents degrees of freedom. Okay, and your air is diatomic. Okay, so your F is 3 for mono, 5 for dia. So Newton assumed this correction and he took gamma is equal to 1 plus 2 by 5, so that will give you 7 by 5, which is gamma is equal to 1 by 4. So for diatomic gases, your gamma is 1 plus 2 by 5, that is equal to 7 by 5, which is equal to 1.4, and he took V is equal to under root gamma into P is atmospheric pressure if you take the normal conditions, rho is density of air. Okay, mainly it consists of oxygen, nitrogen, carbon dioxide. Combining all this, he gave your velocity of sound is, okay, in some books it is 340 meters per second and it is in some books it is 332 meters per second. And this sound wave velocity, Okay, it depends on medium. Okay, and temperature also. And if you want variation of sound with the temperature, your velocity of sound with respect to temperature is given as v at 0 times 1 plus t by 546. Okay, this is velocity of sound at 0. Okay, 0 degree centigrade. This temperature is T in degrees centigrade. This is in sounds. Okay, now this information has nothing to do with Doppler effect. Okay, so Doppler effect I will use only one thing, that is velocity of sound. Okay, so I am just doing a recap of what you have learned previously. Now, what is your Doppler effect? I'll put it in a simple way. If you look into the books, you will get terrified. Okay, so please do not be afraid if you see new things. Okay, I'll make the subject simple and easy for you. Now, what is this Doppler effect? I'll tell you. So, your Doppler effect is, if you have a source, what is this? A source. What is this source doing is, it produces sound. Okay, the source will produce sound. When the source is producing sound, okay, when the source is producing sound, let us say there is a listener. Okay, he could be in rest or motion. This source could also be in rest or motion. Okay, now if the source is producing some frequency, okay, if the source is producing some frequency which is equal to f naught. What is f naught? F naught is frequency of source. Now what will happen is, the frequency of sound heard by listener, frequency of sound heard by, okay, heard or received, okay, heard or received by listener is, okay, is equal to f naught. It is not equal to f naught. When it is equal to f naught, when it is not equal to f naught means, it is equal to f naught when there is no relative motion. Okay, when there is no relative motion between source and observer, between source and observer. Okay, so no relative motion between source and observer means, if you are standing on one of the bodies, okay, other must be at rest. So when there is no relative motion, that frequency heard by listener will be same as frequency of source. And when there is relative motion, okay, when there is relative motion, when there is relative motion, okay, so what will happen? That frequency heard or received is not equal to f naught. Okay. Now this frequency heard by listener is called as apparent frequency. This received frequency is also called as apparent frequency. Okay. This received frequency is also called as apparent frequency. Okay. Now if you are asked beat frequency is difference in frequencies. Okay, apparent frequency is frequency received by the listener. Okay, so now I want you to first copy this stuff down, and if you have any doubts, just let me know. Now your next idea is, okay, just remember these points. Okay, now our target in the Doppler effect is, okay, you will have source velocity. Vs is equal to, in books this will be, in some books it will be velocity of sound also, but according to what I am taking, Vs is velocity of source. Okay, and V is velocity of sound. Okay, and W, according to my habit, it is velocity of wind. Okay, and there will be some observer or listener. Observer or listener means person who is actually receiving the frequency. Observer or listener is another word. Okay, and your observer or listener will have V is equal to, okay, VO. Okay, VO is velocity of observer or listener. Okay, so these are the terms that I am going to use. Now your F naught, okay, F naught is frequency of source. F naught is frequency of source. Okay, and your F apparent, okay, your apparent F apparent is apparent frequency. Okay, now our target is this apparent frequency. Out of this, okay, what is this target is, information will be given to you with out of these some values. Okay, information will be given to you in the question. Okay, information will be given to you in the question. Okay, with some values, with some values. What is that you are supposed to do is, okay, calculate the unknown. Calculation of unknown variable is your ultimate target. Unknown variable, or they could ask you like, okay, beat frequency. Okay, most of the questions will be like calculation of unknown variable or beat frequency. Okay, so some information will be given and some will be unknown, so we are supposed to calculate those unknown values. Okay, so this is the terminology I am going to use. Okay, and remember, okay, remember the direction of sound. Okay, direction of sound wave will always be towards the listener, will always be towards the listener. Okay, so please do remember this. Okay, these ideas you keep in mind, take time. Okay, whatever symbols I am using, you just remember these things, you just copy it down, relax. Okay, now a simple trick I will give you, and using that you can do almost all the questions easily. Okay, come on. Okay, first copy it down. Now your next important idea is, if two bodies move in opposite direction like this, your relative velocity, velocity of A with respect to B will become, okay, it is VA I cap minus VB I cap. So eventually it is VA plus VB. So when bodies move in opposite direction, velocities tend to add up. When bodies move in same direction, okay, when bodies move in same direction, your velocities tend to subtract, right? So VA I cap minus VB I cap, because both are towards right. Okay, so it will become VA minus VB. So relative velocity is what I will take. Okay, so what is your Doppler effect statement is, okay, when bodies move, okay, when, okay, instead of bodies I'll use the word, when source and listener move in straight line. Source and listener move in straight line. Okay, what will happen is, when the source and listener move in straight line, okay, what is going to happen is, your frequency, okay, your frequency, okay, apparent frequency is velocity of sound, velocity of sound with respect to observer by velocity of sound with respect to or relative to means both will mean the same, velocity of sound with respect to source times f naught. Okay, very simple. So here we are considering relative velocity, same direction you have to, okay, keep minus, opposite direction you have to keep plus. Okay, and I'll write a note here. Okay, if wind direction is same as sound direction, wind direction W is, okay, W is wind speed, okay, same as that of sound, wind direction is same as that of sound, your velocity in place of V you have to replace with V plus W. And if wind direction is, okay, sound velocity is V plus W, and if wind direction W is opposite to that of sound velocity, okay, then it is going to become V minus W, okay. So keep this point in mind, and using this we will be doing lot of questions and you will be able to do it easily. Okay, so come on, please do remember this idea. Pause the video clip if required. Okay, close your eyes. Remember the basic idea that is happening here. Remember this relation, and then directly we'll jump into the problems. Okay, come on. So now let us do different simple examples and situations. Case 1. In the problems they'll give you different values, don't worry. So you have a tuning fork that is at rest. You have an observer or listener, he is also at rest. Now this is producing a frequency of f naught. What is your apparent frequency received in this case? F apparent is how much? Come on, give it a try. Case 2. Now what will happen is your source is at rest. Now observer moves with speed of VO. Okay. Now what is your apparent frequency? Okay. Come on. Pause the video clip. Take a minute time. Give it a try. Assume V is velocity of sound. Okay. And frequency produced by source, even though I did not mention, it is some F naught. Okay, come on. And if nothing is mentioned, there is no wind at all. So what will happen is your sound will travel with V towards listener, obviously. Your observer, he is at rest. So V minus 0. What is this? Velocity of sound with respect to observer by velocity of sound with respect to source. Source is also at rest. So it is F naught. So your apparent frequency is F naught only. Okay. Reason is there is no relative motion. Okay. There is no relative motion between source and listener. There is no relative motion between the source and listener. Okay. Right. Next. Your next part is, okay, coming to the next bit, your sound will travel this way. Now your apparent frequency is, because both are in same direction, velocity of sound with respect to observer. Sound is traveling towards right, observer velocity is also towards right. So same direction. So V minus V naught by velocity of sound with respect to source. Source is at rest. So that is why it is V minus 0 times F naught. Okay, right? So hope you have understood this. Okay, now next let's move on to case 3. Okay, pause the video clip and if required copy this stuff down. Case 3, your third case is, this is at rest and your listener is coming close with velocity V naught. It is producing some F naught. Okay, now in this case, what is your apparent frequency? Try it. Case 4. This source listener is at rest. This source is going with Vs this way. Now, what is your apparent frequency? Come on. So, velocity of sound in the problems, in place of V, you have to substitute 330. Okay, unit conversion, if required, you have to take. You have to take care of all this stuff. Come on, give it a try. Okay, so your apparent frequency, what it is in this case is your sound will travel this way. So your apparent frequency is V plus V naught by V minus 0. Velocity of source is 0 times F naught. And in this case, how much it is means, okay, hope you have paused the video clip and then tried it sincerely. So in this case, if it is V, okay, here observer is at rest. So it is V minus 0 by, it is V plus Vs, because your sound will always travel towards the listener. I have told you, sound always travels towards the listener. So V minus 0 by V plus Vs into F naught. Okay. Hope you have understood this and there are no doubts. And if you have any doubts, just please let me know. Okay. Copy it. Continuing further, we have finished 4 cases. Case 5 is your observer is at rest. Your source is producing a wave of frequency f naught and it is coming close towards the listener. Now, what is your apparent frequency? Then, case 6. What is happening is, in case 6, this is moving towards right, this is moving towards left. Both are in motion. In this case, what is your apparent frequency? Come on, give it a try, those who are watching. Pause the video clip, give it a try. Hope you have tried for sufficient amount of time. Now, your apparent frequency is, your sound will always travel towards the listener. So, V minus 0 by, now it is V minus Vs. Okay, always usually velocity of sound will be greater than velocity of source. Okay, 340 meters per second is a very big value. So, you have to take V minus Vs only. And in the next case, sound will travel this way. So, it is V minus V naught by your value of velocity of sound with respect to sources, because they are in opposite direction, V plus Vs into F naught. Okay. Next, case 7. Alright. So, next is case 7. Your source is moving this way. Observer is moving this way with speed V naught. Now, in this case, what is your apparent frequency? So, obviously, what happens? Your sound wave will always travel towards the listener. So, your apparent frequency will be V plus V naught by V minus, V plus Vs into F naught. Okay, because they are traveling in opposite direction. Okay, alright, next. Hope you have copied it down. Case 8. Your source and listener both move towards each other. This produces a frequency F naught. Now, what is your apparent frequency? So what will happen in this case? Sound travels this way. So it is V plus V naught by V minus Vs into F naught. Okay. So what are these basic cases? Okay. So far I have discussed, okay, all the basic cases and hope you have understood all this. Okay. Now let's directly, okay. Now I'm doing a question. So I have given you a question. So please pause the video clip and then try it. Okay. Come on, try it for a minute. Then I'll discuss the solution. I'll discuss the solution. Now, while it is coming this way, this fellow is at rest. So now your first apparent frequency f dash received is, okay. So velocity of sound with respect to observer v minus 0 by velocity of sound with respect to source. So source Vs is given as 220. So it is Vs v minus Vs times f naught. So it is 330 by 330 minus 220 into f naught. Okay, fractional change is asked, whatever it is. Okay, so we don't know the f naught, but yes, fine. So 33 by 11 means it is 3 times f naught, I suppose. Next, while it is going away, your sound comes this way, your v is this way, and your velocity of source is this way. So f dash, velocity of sound with respect to observer, v minus 0 by velocity of sound with respect to source, v plus vs into f naught. So that will give you 330 by 330 plus 220, that is times f naught, that will give you approximately 33 by 55 means it is 3 by 5 f naught. Okay. So now what is your fractional change is change by initial value. So it is f double dash minus f by f dash by f dash. So it will become 3f naught by 5 minus 3f. Okay. So 3f naught by 5 minus 3f naught by 3f naught. So it is around minus 1 by 5, I suppose. 3f naught will cancel off. So 1 minus 15 by 15. Am I correct? So how much you are getting? Simplifying 330 means, sorry, this is 1 by 5, not 3 by 5. Okay. So 1 by 5, 1f naught by 5 minus 3f naught by 5, I suppose. Okay. Am I correct? Hope so. Okay. No, wait. It is 3 by 5 is correct. Okay. Simplified it is 33 by 55. 33 by 55 into f naught. 11 3s, 11 5s. Yes, it is 3f naught by 5 only. Yeah. 3f naught will cancel off. So you will get 1 by 5 minus 1. 3f naught will cancel off in the numerator and denominator. So 1 by 5 minus 1 minus 4 by 5 minus 0.8 is the answer. Yeah, you are matching with the options. Yes. Okay. Right. Okay. So your next question is this. Okay. Pause the video clip, relax, read the question properly, then try it. So because this is a factory, obviously it will be at rest. Sound direction and wind direction both are same. So it is V plus W. It will produce a frequency F naught, and some person Okay, he is riding the scooter. Okay, and he will move with velocity of observer. Okay, so now what is the answer is velocity of observer is 36 kilometers per hour, means 36 into 5 by 18, 18 ones, 18 twos, 10 meters per second. Velocity of sound, you take it as 340, whatever. Okay, I should have mentioned in the question. So, velocity of sound 340 meters per second. Okay, so wind direction, wind velocity is 54, means 54 into 5 by 18, 18 ones, 18 threes, so 3 5s are 15. So your apparent frequency f dash is velocity of sound with respect to source, observer by velocity of sound with respect to source is at rest, times f naught. So 340 plus 15 minus velocity of observer, it is 10, whole divided by 340 plus 15 times what is the frequency, 600 hertz. So this is your apparent frequency heard by the person driving the scooter. Okay, now if wind is blowing opposite to direction of wind, in place of v plus w you have to keep v minus w and then solve the question accordingly. Okay, right? Next. Okay, now your next case is Doppler effect when velocities are not along straight line motion. Okay, so how to do that I will tell you. For example, let us say there is a source. This source is moving with some velocity vs. Now there is an observer, he is at some point O and he is at rest. Now if this angle is theta, now what will happen is your sound will always travel towards the listener. Now if the source produces frequency of f naught, okay, what will happen is by the time the source keeps sending waves, okay, by the time the source keeps sending waves, by the time sound wave reaches, okay, from point, let us say this is some a, okay, I will take this as some a and this as some b, this is some other point c, okay, it need not be in straight line, it can be somewhere here, it doesn't matter. So depending upon the value of velocity of source, it can take different positions. Now what will happen is by the time your sound travels, okay, the whistle produced by the source, okay, it travels with speed of sound which is 340 meters per second. Okay, by the time it travels from A to B, your source will travel from some A to C like this. Okay, so now they can ask you what is the distance AC, what is the distance AB or some angle depending upon whatever is given. In all these cases, how do you actually apply Doppler effect is, okay, whatever is given, just resolve the velocities, okay, resolve the velocities along the line of motion, okay, along the line joining the 2 points. So at this instant, okay, your velocity of source component perpendicular to line joining these two is Vs sin theta. In this direction it is Vs cos theta. Okay, and your sound will travel from here to here. Okay, now your apparent frequency, okay, your apparent frequency is standard logic velocity of sound with respect to observer by velocity of sound with respect to source times f naught. Okay, so what will this become is velocity of sound with respect to observer means, okay, so what will happen is velocity of sound with respect to observer means, okay, so your observer, he is at rest, so it is v minus 0. Okay, sound wave will still travel along the line joining the source and listener. Okay, so v minus 0 by, because these two are in same direction, it is v minus vs cos theta into f naught. Okay, because they are in same direction. Okay, because they are in same direction, this is your answer. Okay, so this is just a simple basic example. Okay, example 1, provided if this angle is theta, don't mug up this result. In some books, instead of giving this angle theta, this pink color angle some alpha could be given. If that is given in place of Vs, you have to keep Vs sin alpha. Okay, according to my figure. Okay, according to figure, this is cos theta here. Okay, keep that point in mind. If it is changed, if that angle alpha is given, you have to substitute Vs sin alpha. Okay, alright, next example 2. Okay, right. So next case is, let us say the source is moving this way. Okay, for understanding sake, wait, I will put a note and write down. Next example I will discuss that. Note, your apparent frequency is velocity of sound with respect to source by velocity of sound with respect to, sorry, observer by source. Okay, with respect to observer by source times f naught, okay, is valid. Okay, valid only when they are in straight line. Okay, if not, what is it we are supposed to do? If they are not in straight line, if the velocities are not in straight line, resolve the velocities, okay, along the line joining source and listener. Okay, now remember that, okay, remember the fact that if something is unknown, okay, still you can apply this logic and do that. Okay, through examples I will discuss, so you don't need to worry. Okay, so those who want to copy it down, please do copy it. Kunnarankuntunna. Alright, now next, your next example is, let us say you have your source here and let us say your listener is here and this listener is at rest. Your source is moving like this and your listener is here. So what will happen is this will produce a frequency of f naught. So what is the apparent frequency here could be the question. Let us say this angle is given as theta. Okay, find apparent frequency. Come on, give it a try. What will you do? You will resolve this velocity of source into two things, Vs sin theta and Vs cos theta. Okay, sound wave will travel with velocity v this way. Listener or observer is at rest. So your apparent frequency is v minus 0, velocity of sound with respect to listener. Any of E is at rest. Okay, v minus 0 by velocity of sound with respect to source, v plus vs cos theta, because v and vs cos theta are in opposite direction. I told you, okay, in the starting of this video clearly that if they are in opposite direction, relative velocities will tend to add up. Okay, so like this you are supposed to simplify and then do different questions. Okay, now based on this, let us see an example. Okay, so you basically have a situation like this. There are two trains which are moving in same direction like this. Okay, both will move with 20 meters per second. Distance between the trains is 2400 meters, and somewhere here you have your observer. Okay, so that observer is at a distance of 500 meters. Both the source or trains will produce a frequency of 500 hertz. Okay, if speed of sound is 340 meters per second, what is the frequency heard by the person? Okay, that is your question. Okay, and an extra question if you want to write here, find beat frequency. Okay, this is your first bit. Second bit is beat frequency. Come on, try it. I'll help you out anyhow later. So give it a try. Those who are watching, pause the video clip, try it sincerely, then I'll continue. Okay, so the answer to this question is, if this angle is theta, this distance is 1200. If you resolve this 20 cos theta this way, the 20 cos theta is velocity of source, v is also this way, observer anyhow he is at rest. So frequency, apparent frequency of A is f dash if you assume. Okay, it is v minus 0 by v minus velocity of source cos theta into f naught. Okay, here if you join this angle, if this is theta, your vs is this way, this angle will be theta, so vs cos theta will be upwards and your v will be downwards. So f double dash is v minus 0 by v plus vs cos theta, because they are in opposite direction, times f naught. Okay, now cos theta is adjacent side by hypotenuse. So from geometry, your cos theta value is 12 by 13. So v value is given as 340 by 340 minus, what is velocity of source? 20 times cos theta is 12 by 13 times frequency is 500. Here it is 340 by 340 plus 20 into 12 by 13 times f naught, which is also 500. So simplifying here, the final answer that you are going to supposed to get is 529 hertz here, and it is 474 hertz, your beat frequency. So this is your first bit answer. Your second bit answer is beat frequency is mod of f double dash minus f dash, or you can write mod of f dash minus f double dash. There is nothing wrong. Whatever is the difference, that is your answer. Okay, if you have any doubts, just please let me know. Alright, now I'll move ahead. Okay, next situation is, they can relate basic questions like this. For example, let us say there is a body and that is going in a circle like this, and let us say you have an observer or listener. Okay, so this is your observer or listener, and let us say this angular velocity is omega, linear velocity of a body is v, and radius is equal to r. Okay, now what will happen is, if this radius is r, if this radius is r like this, they could ask you questions like this: find maximum or minimum frequency possible. They can ask you like this. okay, and this velocity of source, okay, observer, he is at rest. Okay, they could give you angular velocity omega like this. Okay, now velocity of source they will not give you, but they will give you a question like this, and let us say frequency of source is given as f naught. Okay, now I told you and I've been telling you. Okay, so this maximum frequency and minimum frequency, when it will be there, I will tell you. So maximum frequency and minimum frequency. When you will have maximum frequency and when you will have minimum frequency, I'll tell you. So you will have, okay, you will have maximum frequency when, okay, you will have maximum frequency when, okay, source and listener come close together. Okay, so when they are close enough, you will have, okay, come close together or the distance is decreasing, okay, then you will have maximum frequency. Minimum frequency will be there, okay, when source and listener, okay, they move away, okay, they move away, indirectly distance is increasing. Okay, so that is the thing. So now here what will happen is, okay, so if you take this body, okay, if you take this body, okay, and if this radius is r, your velocity of source, if it is some position A, position B, okay, just hold on. So if this is some position B, if this is some position C like this, and if this is some position D, now observe carefully, when the listener is here, okay, now in all these cases your velocity of source is same, which is equal to r omega. Here also your velocity of source is equal to r omega. Now if you take this situation, okay, when the sound produced, okay, when the sound produced is in this position, okay, that is position B, and sound produced by the source in this position D, if you take, okay, so when that position is there, then you will have that straight line orientation. Okay, so indirectly there is parallel, okay, they are parallel kind of stuff with the listener. But in any other position if you take, you will either have component, okay, if Vs is this way, then it will have two components. If this angle is theta, you will have Vs cos theta and Vs sin theta. Any other position you take, there will be components. So the deciding positions are, excuse me, so the deciding positions are, okay, only two positions. One is B and other is D. Okay, so this deciding positions B and D for you to do it. Okay, so the deciding positions will be, okay, the deciding positions will be, okay, so maximum frequency will be, I told you, when they are in, okay, source and listener, they are trying to come close. So maximum will be there at position D. Okay, position D you will have maximum. How much it is means V minus 0 by V minus Vs, which is equal to R omega times F naught. And if you take position B, okay, you will have minimum frequency. That minimum frequency is V minus 0 by, okay, it is V plus R omega into F naught. Okay, if you look at this, the denominator, if it is minimum, numerator will be, the left hand side term will be maximum. Okay, so here if you look at this, V minus R omega. Here if you look at this, V plus R omega. Okay, so these kind of questions similar to this also you are supposed to simplify and then do it. Okay, all right. Next, your next set of questions will be, okay, relating these questions with, okay, they could even give you time period. So time period is 2 pi by omega. You can do that and then simplify. Okay, right? Next, okay, in problem solving sessions I'll add more questions. Okay, your next idea is, okay, frequency of reflected sound. Okay, frequency of reflected sound. Okay, so what is this frequency of reflected sound? I will tell you, observe carefully. Now let us say there is some kind of source, it is moving with some Vs. Let us say there is a wall here. Okay, now what will happen is, if this produces, okay, if this produces sound with velocity v, what will happen? This wave will strike the wall and then it will come back like this. Okay, so if this strikes the wall and then comes back, okay, so this will become, okay, I mean, the after striking this will receive some frequency. So if the observer is somewhere here, okay, this listener or observer, whatever frequency he will receive, that is your, okay, reflected frequency. Okay, so original frequency, there will be two frequencies here. Okay, this listener, he will receive two frequencies. Okay, first one is directly from source. Okay, directly from source. Second one is, okay, because of reflection or after reflection from wall. Okay, because of reflection, or I can say after reflection from wall. Okay, so after reflection from wall, two frequencies are possible here. Okay, so these frequencies we are supposed to calculate. Okay, so direct one you can apply Doppler effect directly for this. Okay, direct Doppler effect formula. Okay, but for this how to do it I'll tell you. Okay, so for this situation, okay, what is that you are supposed to do? Okay, so clearly I'll write down the steps. Okay, so what I write is steps for calculation of reflected frequency from wall. Okay, so now let me put it in simple terms. Okay, first step is step 1. Okay, make wall as listener and calculate frequency received by wall on f dash. Okay, next step 2. Okay, your second step is, okay, make wall as source, make wall as source which will reflect, okay, which will reflect, okay, which will reflect a frequency of f dash. Okay, which will reflect a frequency of f dash. Okay, I mean, which will produce, okay, which will produce, okay, so rather than reflection, which will produce a frequency of f dash. Okay, basically it is coming because of reflection. Okay, so comes because of reflection only. Okay, so it comes because of reflection. Okay, next step 3. Okay, your third step is, okay, uh, not required. Okay, directly what is there? Okay, calculate. Okay, step 3 is like apply Doppler effect between, apply Doppler effect with between, okay, listener and wall, okay. So that will give you f double dash, okay. So you will get f double dash is equal to f naught, some constant into f naught, okay. So this is your frequency of reflected sound, okay. So that is what you have, okay. So please do copy this stuff. If you have any doubts, just let me know. Now, what is your question is, there is a person, okay, he is doing some band, okay, he is carrying some uh, instrument and he is producing some band this thing, okay. So band means indirectly musical band, so I'll keep it as some source, okay. What is happening is, okay, this band is producing a frequency of f, okay. He is moving with speed vv. A motorist is moving, okay, he is going in some car, okay, this is your car, okay. He is going following the band with a speed of vm, okay, motorist, okay, this is motorist, okay, and there is a big wall here, okay. So speed of sound is equal to v, okay, this is your wall, okay. Question is, find reflected sound frequency. Number 2, okay, beat frequency, okay. Second question is beat frequency. First question is reflected sound frequency, okay. Come on, give it a try. I'll explain the solution, okay. Stick to the steps that I've given and try to do the answer, okay. Hope you have paused the video clip and tried the answer for sufficient amount of time. So I'll continue. Now one frequency will be between these two, okay. Now from the language of the question, directly for one frequency this motorist is the listener, okay. Now for the reflected one also he is the listener. One is direct, okay. So direct one events, okay, direct f direct is, okay, apparent direct is, okay, sound will travel this way, velocity of sound with respect to observer, so v plus vm by velocity of sound with respect to source, v plus vb times f naught, okay. So what is this? Direct, okay. Direct frequency what he is getting, okay, because the band is moving in the same direction, okay. So this is your motorist what he receives directly, okay. So sound will travel from band to the motorist directly, okay. Next, is there anything wrong? Everything is perfect. Velocity of sound with respect to observer by velocity of sound with respect to source into frequency f naught. This you have to substitute in beat frequency later. I will focus on reflected frequency. Now, when you are calculating this reflected frequency, okay, what did I tell you? First make wall as the source, okay, forget about the motorist, okay. So frequency received by wall. So what is that you have? This wall could even be moving, still same logic. So wall is the listener. Source is coming with speed vb, sound is coming with v. So if wall is the listener, this wall is at rest because the wall is not moving. Your frequency received by wall f dash is velocity of sound with respect to observer v minus 0 by velocity of sound with respect to source v minus vb, because both are in same direction, times f naught. Okay, next, your f reflected is, so now what is it you have? You have motorist as the observer. He is moving with speed Vm. You have the source. This source will produce a frequency of f dash, and this is at rest. Your sound will travel from this source. So your f double dash or reflected frequency is velocity of sound, okay, with respect to observer, that is v plus vm, by velocity of sound with respect to source v minus 0 times f dash, that is equal to v plus vm by v times f dash is v by v minus vb into f naught, that is your f double dash. Okay, so like this you are supposed to calculate the reflected frequency. Now what is your beat frequency means? Okay, your beat frequency is this will cancel off. Okay, your beat frequency is mod of f double dash minus, first I have calculated this direct value, no, that value will give you the final answer. Okay, so like this you will have some interesting questions and basic questions. You are supposed to do those questions. Okay, now they could even give you questions like where the wall is moving or hill is moving, something like that. So you should not get worried at all. You have to stick to the basics. Okay, in the problem solving session some more ideas will be added to this. Okay, so just please have a look at it, and if you have any doubts just let me know. Alright, so we'll continue with where we have left off in the previous topic. Okay, so the question is like this: you have a wall which moves with speed u, you have a source who is moving with speed vs. Okay, vs is not velocity of sound, your vs is velocity of source, and let v be the velocity of sound. What is your question is, you have a listener, find frequency after reflection, second beat frequency. Okay, so that is your next question. So please do try to give the answer. Those who are watching, you can pause the video clip and then try to give the answer. Okay, so now what is the answer is in this scenario? Okay, so first, okay, let us try to calculate reflected frequency calculation. So reflected frequency calculation, I'll do it first. So what is your first step is make wall as listener. So if you make wall as the listener, so that means indirectly there is somebody who is standing on the wall. You have a source which is actually sending sound with speed v, and source is moving with vs, wall is, observer is moving with u. Now frequency heard by wall is apparent frequency. Okay, according to our formula, velocity of sound with respect to observer by velocity of sound with respect to source times f naught. So how much is it means velocity of sound with respect to observer is, so it is v plus u because they are traveling in opposite direction, by velocity of sound with respect to source is v minus vs into f naught. Okay, So what is this? Frequency received by wall. Okay. Now next, let us try to calculate the frequency received by, okay, let us try to calculate the frequency received by the receiver because of the wall. Okay, now wall is the source, so which is producing sound in this direction. It is moving with speed u. Okay, so indirectly this is your new source. Okay, so this is your new source and it is producing a frequency of f wall, and your listener, he is at rest. Okay, original listener, he is at rest. Let us say in the question it is given that he is at rest. Okay, so now f reflected that he receives is velocity of sound with respect to observer, v minus 0, because the person is observer here, he is at rest. So v minus 0 by velocity of sound with respect to source, it is v minus u. Okay, it is v minus u because both are in same direction, times what is the frequency given by wall means f wall. So your final answer is v minus u times what is your frequency because of wall means it is v plus u by v minus vs into f naught. So your final reflected frequency is this much. Okay, hope you have understood the question in detail and there are no doubts. Okay, now let us try to calculate the beat frequency. Now for beat frequency, okay, I'll try to change the color. So beat frequency answer is, your beat frequency observed is, okay, mod of f direct minus f reflected. So f direct, what is it you are supposed to do? Try to apply Doppler effect between these two. Okay, so I'll try to use a different color. So take this pink color box, apply Doppler effect between those two, you will get the direct frequency. Okay, right. Now for understanding sake, let me add one more question. So your next question is, okay, a similar scenario. You have the person moving with speed u, source is moving with vs, and let us say wall is moving with, okay, let us make velocity of observer as vo. Okay, not even u, it is vo. Wall is moving with v wall like this. Okay, so it is in the same direction or opposite direction, whatever. Okay, stick to the basics. Now question is, find reflected frequency heard by listener. Okay, Doppler effect you can apply, beat frequency, it is easy. So the question is, find frequency heard by reflected frequency. Okay, correct term is reflected frequency heard by listener. Okay, so come on, try it sincerely. Okay, so you will get the answer anyhow, don't worry. Please do try it. Pause the video clip and then try it. Okay, so once again same steps. Making wall as listener. Okay, I have given these steps how to do these questions. So if you make the wall as listener, wall is moving with v wall like this, source is moving with vs, sound comes from source with speed v. So frequency received by wall is f wall is equal to velocity of sound with respect to observer, velocity of sound with respect to observer by velocity of sound with respect to source times f naught. So whatever initial frequency, okay, assume that it is producing some frequency of f naught. Okay, it is given in the question, let us say. So now what will happen is, your velocity of sound with respect to observer, wall is the observer, they are in opposite direction, so it is v plus v wall whole divided by velocity of sound with respect to source, v minus vs into f naught. Now what is it you are supposed to do? We are supposed to make wall as source, make wall as the source. Now if you make wall as the source, it will produce a frequency of f wall. It will produce sound with speed v, and it is moving with v wall, and you have an observer here who is moving with v naught. Now what is your reflected frequency is velocity of sound with respect to observer by velocity of sound with respect to source into f naught. So if that is the case, velocity of sound with respect to observer. Now who is the observer means that person who is moving with v naught, he is the observer. So now what is the direction means v plus v naught, because your v and v naught are in opposite direction, by source v minus v wall times frequency produced is f wall. So that is equal to v plus v naught by v minus v wall times frequency produced by wall is v plus v wall whole divided by v minus vs into f naught. Okay, so this is your reflected frequency and your final answer. Okay, so like this you are supposed to simplify and then give the answers. Okay, alright. Now basic questions you will be able to do it. I don't need to discuss much in those lines. However, let us see any good questions if they are there. Let me give you. Regarding any acceleration in advanced level questions, you will have it. Right now this much is enough. Next, a small portion is there. Alright, so our next topic is your Doppler effect in light. Now this is similar to your Doppler effect in sound, but here you will have two terms what are called as blue shift and red shift. So what is it exactly, I'll explain now. Okay, now first and foremost basic idea is, okay, we have seen that when observer and source are in relative motion, the apparent frequency is what? Frequency heard by listener. Okay, so this apparent frequency is frequency heard by listener. Okay, is different from original frequency. This is what I have given, and for this we have seen that what is the formula, that is your apparent frequency is velocity of sound with respect to observer by velocity of sound with respect to source times f naught. Okay, now here, okay, I want you to understand few important few important ideas first itself. Now when it comes to sound and when it comes to light, what is happening, I will tell you. Now if you take sound, for example, if you have a source and if you have listener at rest, and this source is moving at some speed vs and sound produced is v. Now in this case, what is your frequency means? Okay, your frequency is your apparent frequency. F apparent is what? It is velocity of sound with respect to observer, v minus 0 by v minus vs into f naught. Now another example, if you take, if you make the source at rest and if you are making this observer go towards the source with some speed v naught, then if this produces v, your apparent frequency in this case is v plus v naught by, okay, velocity of sound with respect to source v minus 0 into v naught. This is what I have done in sound. Now observe very carefully here. Okay, they are approaching each other. In both cases approaching is happening. Okay, approaching is happening in both the cases. Now your apparent frequency depends on apparent frequency here it is dependent on, okay, I can say apparent frequency is dependent on, okay, so your apparent frequency is dependent on whether source is moving or listener is moving, source is moving or listener is moving, okay. Now when it comes to light, okay, when it comes to light, very clearly I'll write, okay, as long as they approach, okay, as long as they approach, okay, apparent frequency will have same value in both cases, same value in both case, okay. It actually depends on your relative velocity, okay, that velocity of approach is the key thing. When it comes to sound, which is moving, that will decide, okay. In one case you got one answer, in the other case it is different, but when it comes to light you will have same answer for both the cases, okay. So for that I will tell you, okay. So here when it comes to light, okay, according to relativity, okay, according to theory of relativity, okay, I mean normally if you take classical mechanics, if some body is moving, okay, with some speed v1 like this, and if some other body is moving with speed v2 in opposite direction, I mean in same direction, your relative velocity you are writing v1 minus v2, okay. But if you consider with the speed of light, okay, if this comes with speeds close to speed of light, okay, if speeds of lights are considered, okay, then you cannot apply v relative is equal to v1 minus v2, such kind of stuff. Relative velocity is not meaningful when it comes to relativity, okay. So you will get confused, you cannot apply, you cannot write v1 minus v2 if you are standing, one object is moving with speed of light and some other object is moving with speed of light, c, you cannot write relative velocity c minus c 0, something like that, okay. So that and all you will study later, but I want you to understand that, okay, you cannot apply theory of relativity as such, okay. So according to relativity, okay, you cannot apply relative velocity ideas what you have learned in mechanics, okay. So relativity, I will write this according to relativity theory, okay, we cannot apply classical mechanics ideas of relative motion, ideas of relative motion for objects which move with, for objects which move with speed close to speed of light, okay. You cannot do that, okay. For objects which move with speed close to speed of light, you cannot apply relative velocity, okay. So that is the problem. So to overcome this, okay, to overcome this, okay, we are talking of big stars, such kind of stuff. So what is that you will do is, okay, what is that you are going to do is, you will broadly discuss this into two cases, okay. One is approaching star. For this you will apply Doppler effect. You are standing on earth and star is coming, okay. So we are on earth or approaching star with respect to earth, and other one is receding star, okay, receding star. So indirectly what is that I am doing is, I can apply Doppler effect to these two cases, okay. So here it is distance between the stars is, distance between stars is, okay, uh, decreasing here. Here distance between the stars is increasing, okay, distance between stars is increasing, okay. So stars, I mean stars are any big objects, okay, with respect to earth, something like that, okay. So now what is this, I will tell you, okay. So our scenario will be like this. Our basic scenario is, you will have earth or some object like this, you will be standing here, you are your observer and you have some star, okay. Now what will happen is, your earth could be moving, star could be moving. Don't consider these two as different cases. Okay, what I mean is your Doppler effect in this case, if like for example, if earth is at rest and if the star is coming close, or in this case, okay, in some other case, your star is itself at rest. Okay, and this is the source. For example, this is your source and this is your observer, and in this case still this is your observer and this is your source, but let us say earth is moving close to star. In both these cases, here what is happening, distance is decreasing. So distance is decreasing, so we call this as blue shift. I'll explain, but my point is, for sound, Doppler effect frequency, apparent frequency is different, but for both of these cases, okay, your apparent frequency of light will be same. Apparent frequency of light will be same for both these cases. Okay, I hope you are getting my point. Okay, so your relativity theory, it's different, but my point is, hope you have understood it. There will be apparent frequency as long as relative motion is there, but my key point here is, okay, you will have, okay, my key point here is you will have same frequency. Okay, so in if one is moving, and for approaching star and receding star, what is the apparent frequency, I will give the expressions. Okay, and what is that shift, I will explain. Okay, those who want to take this screenshot, you can. Okay, please do take it. Hope you have understood what I am trying to tell you. I'll tell you how to calculate in case of light. I'll give you the expressions, everything, but please do understand this thing first. All right, now, okay, let us come back. So first, okay, approaching case. Okay, approaching case and receding case. Okay, some interstellar objects, they are receding, and you are on one of the star or some interstellar object, you are somewhere here. Okay, and some other star, something is either coming up or going down. If it is coming up, it is approaching case. If it is going away, it is receding case. Okay, now here, okay, what happens, I will tell you now. Okay, we know that, okay, we know that your velocity is frequency into lambda. In case of light, your v is speed of light, which is equal to f into lambda. Now in approaching case, okay, similar to sound waves, okay, when bodies come close, what will happen? Okay, when the source is coming close, frequency increases, wavelength decreases. Okay, when source moves close to listener, when source moves close to listener, what will happen? If you want, you can observe the previous sound waves case. Okay, frequency increases, wavelength decreases. Okay, and okay, if you take receding case, okay, when the source moves away or distance separation, okay, if separation between the source and listener is increasing, frequency will decrease, wavelength will increase. Okay, here what happens when distance, okay, between, okay, in both cases distance, if it increases, that frequency will increase and wavelength will decrease. If the distance is increasing, okay, distance between source and listener, okay, when the distance between source and listener increases, okay, when distance between source and listener increases, okay, frequency will decrease. Okay, apparent frequency I am talking of. Okay, this apparent frequency will decrease and wavelength will increase. This apparent frequency will increase and wavelength will decrease. Okay, so this already you have seen it in clearly in sound waves. Okay, now in light waves also same logic. Okay, now, okay, in Doppler effect, okay, don't worry how you are getting this formula, but okay, your apparent frequency in case of Doppler effect in this case is, okay, it is f times under root 1 plus v by c times 1 minus v by c, because your frequency will increase now. So overall this expression should have a value greater than 1. So that is why in the denominator it is small and in the numerator it is big. Okay, this is called as blue shift. Okay, this is called as blue shift. Why it is blue shift, I will tell you. And this side it is called as red shift. Okay, this side it is called as red shift, and this side what is your apparent frequency is, okay, your apparent frequency is f times 1 minus v by c by 1 plus v by c. Okay, don't worry how you are getting these expressions. Okay, right, so that belongs to relativity theory, but for now just understand that. Okay, it is like this. Okay, now approaching star, okay, you can remember it like this: ab de Villiers. Okay, approaching star, blue shift. Okay, South African cricketer. Okay, and this side it is like receding star, redshift. Okay, RR. Okay, this is AB, so it is like Rajasthan Royals IPL team. Okay, cricket. Okay, so you can remember it like this. Okay, so receding star you call it as redshift, and approaching star you call it as blue shift. Okay, so now I'll elaborate. Okay, don't worry, feel free, get relaxed, but this is your frequency formula here. This is your frequency formula here when the distance is separating. Now what is v means, here it is velocity of relative velocity of approach. Relative velocity of approach, you are standing on one of the body and you are observing what is the velocity, that velocity, that is your v is velocity of approach. Here your v is relative velocity of separation. Relative velocity of separation. Okay, that means you are standing on one of the bodies and observing the other body. Relative velocity. Okay, it is relative velocity. Here also it is relative velocity. Focus on this. Okay, and c is speed of light. Okay, f is original frequency, and this is your apparent frequency. Okay, now please do take screenshot. Okay, don't worry, I will give much more points. Please do take screenshot. Okay, so now what is this blue shift and what is this red shift, I will tell you. Okay, now if you take this light, okay, it is electromagnetic spectrum. In that, if you take your visible region, it is having VIBGYOR colors. Okay, now when you are moving from violet to red like this, what will happen is frequency decreases, wavelength increases. Okay, from left to right, frequency will decrease, wavelength will increase. Okay, now why is that you are calling it as redshift, I will tell you. Okay, so from left to right, okay, left to right, your frequency will decrease and wavelength will increase. Okay, now if you take this blue shift, okay, why is that you are calling blue shift, I will tell you. Okay, approaching star, we have written approaching star. Okay, approaching star, blue shift. Receding star, receding star, red shift is what I have written. Now this blue shift in approaching star and receding star, what is this blue shift and what is this red shift, let me elaborate. Now I told you, okay, when you approach, what will happen, frequency increases, wavelength decreases. Now if you look at this, let us say somewhere you are near yellow. Now from yellow, if you are moving, okay, from left to right, frequency is decreasing, wavelength is increasing. But now if you move from right to left, okay, right to left, what will happen, frequency increases, wavelength decreases. Okay, left to right, frequency decreases, wavelength increases. Sorry, right to left. Okay, here it is right to left. Okay, from right to left, what is happening, frequency is increasing, wavelength is decreasing. So in case of blue shift, okay, in case of blue shift, okay, why we are calling it blue shift means, if you are somewhere near this yellow, okay, if you are somewhere near yellow, okay, from this yellow, if frequency is increasing means you are going towards blue. Okay, so that is why you call it as blue shift. And if you are somewhere near yellow and if your frequency is, okay, decreasing and wavelength is increasing, that means you are moving towards red color, no, so that is why it is called as red shift. Okay, so using this we can identify actually whether universe is expanding or not, that's a different story. Okay, lot of applications are there because of Doppler effect in light. Okay, scientists will do lot of stuff. Okay, but hope you have understood what is this blue shift and what is this red shift. Okay, so that is why you are giving this name. Okay, now, okay, problems will come from one formula, okay, apart from the previous formulas that I have given. That is, okay, your important formula that you are going to use in both the cases is your change in wavelength delta lambda is v by c into lambda. Okay, right, this is called as Doppler shift. Okay, what is this called? Doppler shift. Okay, which is difference in wavelength, and you can express this even in terms of frequency. Okay, because we know that v is f into lambda, here v is c, so c is equal to f into lambda, means you can write even in terms of frequency. But for now, okay, what is this Doppler shift means? Delta lambda is equal to v by c into lambda, and very very important. Okay, this formula is very important, which we'll be using in the problems. Now, for both the shifts you can apply this formula, and how to apply it I'll explain it to you now. Okay, hope you have understood it and copied it now. Okay, so let us take the approaching star case. Okay, you are approaching star case and receding star case. Okay, I'll get that formula of, okay, delta lambda is equal to v by c into lambda. Doppler shift formula, I'll get it. Okay, so how do I get that? I'll tell you. Now, if I take this fa, I have written it as f times under root 1 plus v by c by 1 minus v by c. Okay, now if you are getting confused here, okay, what did I tell you? Okay, it is f times under root 1 minus v by c by 1 plus v by c. Observe carefully. So here in the numerator, approaching star frequency should be greater than 1, frequency increases, so that is why it is plus in the numerator. This side it is minus. Okay, reciprocal, one is reciprocal of other. Now if you take this scenario, okay, I can write frequency f. Okay, we know that speed of light c is frequency into wavelength. So f can be written as c by lambda a, that is equal to, here f it is c by lambda. Okay, this is original frequency, this is your apparent frequency. F is original frequency, okay, wavelength is apparent wavelength, lambda is original frequency. Okay, so if you want you can copy it later. Lambda is real frequency, real wavelength. Okay, real wavelength, and f comma lambda are real frequencies comma wavelengths. Okay, and fa and lambda a or fr and lambda r are what? They are apparent frequencies. Okay, they are apparent frequencies and wavelengths. Okay, so keep this in mind. Now let us get this expression. So from here I can write it as 1 plus v by c under root whole divided by 1 minus v by c. Cc will go off. Rearranging the terms, lambda a is lambda times under root 1 minus v by c by 1 plus v by c, which can be written as lambda times 1 minus v by c whole power 1 by 2 by 1 plus v by c whole power 1 by 2. Rearranging the terms, okay, in the denominator if it is there, you can rearrange it and write it. So it is 1 minus v by c whole power 1 by 2 times 1 plus v by c whole power minus 1 by 2. Okay, now I'll erase this. Okay, those who want to take the screenshot, please do it, or else you can pause the video clip and copy the terms first. Okay, because of lack of space I'll erase this content. So now if you continue further, this will become lambda times, okay, when x is very much less than 1, 1 plus x whole power n is 1 plus nx, 1 plus x whole power minus n is 1 minus nx. Now your v anyhow it will be less than speed of light. Okay, highest possible value of light, speed is speed of light only. Okay, so this will become 1 minus v by 2c times, this will become 1 minus v by 2c. So that will give you lambda times 1 minus v by 2c minus v by 2c plus v square by 4c square. Compared to these two terms, this is negligible, okay, small. So this will become lambda a by lambda is equal to 1 minus v by c. Shift this v by c is equal to 1 minus lambda a by lambda, okay. Receding star part, I will come to this later because of lack of space, okay. Oh shit. Uh, so what is that we got? Okay, so here I have used the binomial approximations 1 plus x whole power n is 1 plus nx, 1 plus x whole power minus n is 1 minus nx. I have written it this way, keep this aside. Now continuing this step, v by c is how much we are getting? 1 minus lambda a by lambda. V by c is lambda minus lambda a by lambda. So V by C is delta lambda by lambda. Rearranging this definition, Doppler shift formula from here, it is delta lambda is equal to V by C into lambda. Okay. Here in case of approaching star, what is it? Your delta lambda is lambda minus lambda a. Okay. Right. In case of approaching star. Okay, so this is your Doppler shift. Okay, this formula, that is why I told you it is important for problem solving. This only will be using it. Okay, so basic examples I will give you, you will get the clarity. Okay, right. Next, for receding star. Okay, for receding star, how to calculate this, I'll tell you. So for receding star also same logic. So what is your apparent frequency means? Your apparent frequency is, your apparent is f times under root 1 minus v by c by 1 plus v by c, and in this case I'll write redshift fr is equal to f times this thing. Okay, so fr can be written as, I'll change the color. So it is c by lambda r is equal to c by lambda times 1 minus v by c by 1 plus v by c. So CC will cancel off. Lambda red is lambda times under root 1 plus V by C by 1 minus V by C. Lambda R is equal to lambda times 1 plus V by C whole power 1 by 2 whole divided by 1 minus V by C. Okay, because we can write root A is equal to A power 1 by 2. I am using that part. So using the binomial approximation, it is lambda times 1 plus V by C whole power. Oh, wait. Did I do anything wrong? Mm, C by lambda R is lambda times 1 plus 1 minus V by C whole power minus 1 by 2. Okay. So let me simplify this. Power 1 by 2 is there. So lambda times. Did I do anywhere anything wrong? In both cases you should get the same result. Let me check. Hope we'll get the same answer. So hope you will get the same answer. Yeah. So writing this, lambda r is equal to lambda times 1 plus v by 2c plus v by 2c plus v square by 4c square. This term negligible, it is 0. So lambda r is equal to lambda times 1 plus v by c. So lambda r by lambda is 1 plus v by c. Lambda r by lambda minus 1 is v by c. Lambda r minus lambda by lambda is equal to v by c. Yeah, delta lambda by lambda is equal to v by c. So in case of receding star, okay, in case of receding star, okay, your delta lambda is lambda r minus lambda. Okay, so this is your Doppler shift in case of light. Okay, now using this formula you will get very simple basic questions. Okay, I'll pick one or two questions from the standard books. I'll explain those. Remaining you do it from the books. Okay. So try answer to this question. So you have to use standard formula. Delta lambda by lambda is, okay, pretty straightforward. It is V by C, or delta lambda is equal to V by C into lambda. If it is blue shift, approaching star, blue shift, receding star, red shift. Now in this case it is coming towards earth, so it is approaching star, so blue shift. For blue shift, what is the formula you are supposed to take? Okay, so look at this slide. So in case of blue shift, what is it? What is the formula? Lambda minus lambda apparent, right? So your lambda minus lambda apparent is equal to V by C times lambda. Okay, so it is given spectral line emitted by it is 6000 Armstrong. So 6000 minus lambda apparent by lambda, that is once again 6000 only. Okay, that is equal to V by C. What is V? 9 into 10 power 6. What is C? 3 into 10 power 8. From here calculate lambda A. So that way I told you, very important formula, and this is a very powerful equation. Okay, hope you have tried this question. Okay, right? So simplify it. 3 ones, 3 threes. So 10 power 6, 10 power 8 means it is 3 by 100, whatever. You should get the answer as 4.5 into 10 power minus 7 meters. Okay, right? Now your next question is, so your next question is this: what speed should a galaxy move with respect to us so that sodium line at 589 nanometer is observed to be 589.6? Lambda is increasing. So I told you in WebGR, when you are moving from left to right, frequency decreases, wavelength increases. So obviously from 589 to 589.6 nanometer means what shift it is? It is red shift. So your formula delta lambda is equal to V by C into lambda is the formula that you are supposed to use. And if wavelength is increasing, lambda red minus lambda original, okay, because it is increasing, it must be equal to V by C times lambda. So lambda red is, I mean 589.6 minus 589 nanometer is equal to speed V by C is 3 into 10 power 8 times lambda value is once again 589 nanometer. Nanometer unit will cancel off. So it is 0.6 into 3 into 10 power 8 whole divided by 589 is equal to V. So this is your final answer. If you are simplifying it, in the options it is given as 3.1 into 10 power 5 meters per second. Okay, like this your Doppler shift will be there for light and sound. Okay, so with this I have completed the Doppler effect both in sound and light, and very easy question will come and a sure shot question will come, and please do uh, watch this video again and again. If you are not getting something, take any reference book, solve as many possible questions that you can.